Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of binary tree, that is nothing but bottom view of a binary tree. So without wasting time, let's move on to the question. Okay, so yeah, here, so in this question we are provided with a binary tree and we need to tell something about it. Okay, let's try to let it first create a binary tree and then we try to understand the problem statement. So here I'm creating at 3 1 6 0 and 2, it is 5 10 4 15 9 and 11 9 12 13 and 14. Okay, you might be thinking that why I'm laying so much stress while creating a binary tree. It is just because if I don't create this binary tree like that, other means if I will create a binary tree with a little stress, then it will be very easy for you to understand the problem statement. Okay, so without wasting time, let's try to understand. Okay, in this question, what we need to do or what we need to tell is that we just need to tell all those nodes which will be visible to the user if we start looking at this binary tree from the bottom. Okay, if we start looking at this binary tree from somewhere here, if you're looking at this binary tree, okay, so means he can see all these nodes and we just need to tell the data of those nodes. So let's figure out what are all the nodes which will be visible to the user. So what if I say at first this 0 node will be visible to the user. Similarly this, okay, so this 30 node will be visible to this user, this 12, okay, this 14 node will be visible to the viewer, this 10 and this 11. And what if I say only those nodes which I have written here will be visible to the viewer? You might be thinking that how that only these nodes will be visible to the viewer. Let's try to figure it out. Okay, let's try to figure it out. 3 4 5 6, yeah, these these 6 nodes will be visible to the viewers. So at first thing first, we will try to understand for the for the node for this 2 and 5. Okay, at first you can see that both of these 2 and 5 are actually overlapping to each other. Means means at first there may be possibility that either 2 will come at first or either 5 will come at first. Okay, as both of these are overlapping to each other. Now the second point is that apart by even though they are overlapping to each other, but these overlapping are actually get hidden by this 12. Okay, just because you can see that at this particular level, at this particular vertical level, you can see that at first 2 and 5 will come, and at after 2 and 5 the 12, the node having the data 12 will come. So as this node after this 2 and 5, this node having the 12 data will come. So this 12 this node will hide both of this node. That's why when a user start looking from the bottom, he will only be able to see this 12, not this 2 5 or this 3. Similarly, the same type of case happen for this 15 and 9, just because as both of these overlapping, the first thing are that we don't know which node will be available to the user. Similarly, second thing is that this 15 and 9, both of these nodes get hidden by this 14. Okay, so I can say that this 0 4, this 0 13 12 14 and this 10 and 11 are the only nodes which will be visible to the user, just because these nodes are actually not get hidden by any of the nodes, and these are nodes are the children nodes. Okay, these are the child nodes. So second point is that we can't say that all the child nodes will be visible to the user, although only those child nodes will be visible to the user which are actually not get hidden by any of the nodes. So let's try to understand the intuition of this question. Okay, how do we solve it? Before moving to the intuition part, there are some prerequisite for this question. Let's try to understand the prerequisite. The first prerequisite for this question is nothing but the width of the binary tree. Okay, width of binary tree. Why is it prerequisite? Soon you will understand, but I will start explaining the answer, the solution. At that moment you will get why is it important, but it is my request to go and watch that video. The link of that video is in the description box. Okay, similarly the second prerequisite for this question is nothing but vertical level order traversal. Okay, vertical level order traversal. If you haven't watched that video, I can bet that you can't understand it how we'll solve this question. Okay, please go and watch this particular both of this video actually, just because the whole concept of this question is actually based on this vertical level order traversal. And if you have watched that video, then may be a possibility you get it at how we will approach to this question. So without wasting time, let's try to understand it. Okay, so the first thing which I'm going to do is that I'm going to find the what is the vertical level order traversal of this binary tree. Okay, so what if I will ask you what is the vertical level order traversal of this binary tree? You will say that I will make some of the lines like this, and then I can only tell you what is the vertical level order traversal. So let me make some of the lines like this. Okay, and now we know that for the level order traversal, vertical level order traversal, we will make a array list of array list to store our data, and the indexing of the array list start from 0 1 2 3 4 5. Okay, wait, let me create more space. 0 1 2 3 4 and 5, these. Okay, at the zero level, which is the zero level, the zero level is nothing but this. This is the zero level, but we usually mark 0 as the root node, means 0 level at the root node. Why I have written this as 0 level? Just because here we are storing the data in the array list, and the indexing of the array list start from the 0 that I have written here, the level 0 to this leftmost node. Okay, so you can also mark it as 0, and this level as -1, this level as -2, it is as +1 +2 and +3 as per our requirement. But I was just marking it as per my requirement. Okay, now let's move forward. So I hope you get it. Now what are all the data which will be available to the user? What are all the data actually? The vertical when I perform the vertical level order traversal on this tree, on this binary tree, what are all the data which will I get after performing that operation? I'll get nothing but 0 here. Okay, in this case, let me write with the blue. Okay, so in this case I'll get the 0 0 at the left. For this level 1, I get this 1 4 3. Okay, 1 4 and 3. For this level 2, what which are all the nodes which will I get? 3 2 5 and 12. 3 2 5 and 12. 3 to 5 and 12. Similarly here, 6 15 9 and 14. 6 15 9 and 14. At the level 4, I'll get only 10, and at the level 11, I'll get only the 11. At the level 5, I'll get only the 11. Okay, these are nothing but the vertical level order traversal of this binary tree. Okay, I hope you get it, that how I'm able to solve it and how do I get this solution. Just because I personally expect that you have watched that video and you already know how to perform the vertical level order traversal. Now let's move forward. The requirement of this question is nothing but the bottom view of a binary tree, and I have already told you that all the nodes are actually visible to the user. Those nodes were nothing but this 0 node, this 30 node, this 12 node, this 14 node, this 11 node, and this 10 node. Actually, what are all these nodes? If I look at this answer of the vertical level order traversal, what are all these nodes? So I will say nothing but these nodes are nothing but the last node. Means these nodes are the nodes which I access during the at the last during performance of the vertical level order traversal. Means when I perform the vertical level order traversal, the nodes which I encountered at the last are nothing but the solution of this bottom view of a binary tree. So here you can see I encounter this 0. Yeah, I can encounter this 0. This 3, is it visible to the user? Sorry, 13, will it be visible to the user? Yeah, this node will be visible to the user. Similarly, this 12, yeah, this 12 is one of the answer. This 14, yes, here you can see this 14 is will be visible to the user. Similarly, this 10 and 11, this 10 and 11 are the active candidate to be a part of the bottom view of a binary tree. So I hope you get it. How do we approach to this problem? We just know nothing. We will perform the same operation like the vertical level order traversal, and this time in spite of storing all those values, means all the values for each level, what I will do, I will keep on updating the values. Means the moment I encounter any new value for a particular level, I keep on updating it. Okay, so let's have a dry run of this problem, and then we try to solve it on a Pepcoding website. Let me erase it from here. Okay, so yeah, yeah, first let me create a queue to perform a vertical level order traversal, and along with the queue I need to create a array list, okay, to store the data, to store the nodes. But what I'll do this time, do I need to create an array list of array list? No, I don't need to create the array list of array list. I just need to create an array list of a width of a binary tree, and we already know how to calculate the width of a binary tree. So what I'll do at first, let me write the levels. This node will present at level 0, 1, 2, 3, 4, and 5. So I'll put this 3 as my root node into the queue, okay. I'll just put this root node into my queue, so I'm putting this 3, okay. Now I'll perform a while loop, and I'll keep on updating over, keep on working over all the remaining nodes. At first I'll just remove this node, and I'll check that for that particular level, at this level of this node, that is nothing but this 0, sorry, this 2, because here in the array list it will be 2, 0, 1, and 2. And whether at this particular node any data is residing, or any data is residing, or whether the null reside at that position, okay. Just because as a default value I have put here null, okay, means at every position null is present at the default value. Null here also it is null, here also it is null, and similarly here also it is null, okay. Now I will check that whether for this node level, into this array list, whether some non-null value is present or the null value is present. So as there is no null value is present, so I will update this null with the value 3. And as I have removed that value from the this node from the queue, so I need to add all of its subsequent neighbors. So I will add this 1 and 6 into the queue. 1 and 6. Again I'll perform the same type of operation. I'll remove this 1 from the queue, and I will check that whether for this node level into the array list, whether the null reside or some non-null value reside. Here I come to know that a null reside into the array list, so I'll update its position with the 1. Similarly I move forward, I will check for this 6. Okay, yeah, I have removed the 1 before moving on to the 6. I have removed the 1, but I have not added subsequent children into the queue, so I need to add it. I will add 0 and 2 into the queue before moving on to the 6, okay. Yeah, I just forget that small point, okay. So we have already added the children. Let's move forward. We encounter the 6, we will remove it from the queue. We check whether this 6 level means the this particular node level into the array list means this 3 level, okay, whether some null value is present or some null value is present. So here I come to know a null value is present, so can easily update this null value with the with this node value, that is the 6. Let's move forward. As we have removed the 6, let me add its children. That is 6, that is this 5 and 10. This 5 and 10, let's move forward. We reaches to this 0, we'll just remove it. We will ask we will check its level into the array list, and its level is nothing but 0 level. And here while checking, we come to know a null value is present at its level, so we can easily update it. We'll update it with 0. Let's move forward. As 0 don't have any of the children, so we don't need to add the null into the queue. We can easily move forward. So again we remove this 2. Again for this 2, we'll check whether some non-null value is present at this level into the array list or not. But here I come to know some non-null value is present. So according to my question, what I need to do, I just need to tell only those nodes which are visible to the user when he start looking at the tree from the bottom. And what was our approach? Our approach was keep on updating at each level values unless and until means keep on updating the values at each level, and the moment when we completely iterate over the binary tree, we just return this array list. So means we can easily update for each new value at each level. So what we'll do here, we're working on this 2, and we'll check at this level, that is at level 2, and here we come to know some non-null values present, means we can easily update it. So I update this 3 value with this 2, and as 2 don't have any of the children, we don't need to add anything. Let's move forward. I'll just remove this 5, and as this 5 was also present at the same level, means I'll update this 2 with this 5, and as 5 has some children, here 4 and 15. So I'll add these children into the queue again, 4 and 15. So moving forward, I will remove this 10. After removing this 10, I will check at its level, and at its level a null is present. As null is present, so what I'll do, I'll update null with the known null value, and I'll add its children, that is 9 and 11, into the queue. Okay, so moving forward, I encounter the 4. I perform same type of operation for the 4. I will check whether it's at its level into the array list some null value is present or no null value is present. But I come to know that some known null value is present. So means I can easily update the known null value. So I updated with the 4. Okay. So after this one, I have updated this one with the 4. Let me erase this stack values to put some more values. Okay. And let me extend it a little bit more. Yeah, we were working on the 15. Okay, let me erase this 15. Okay, the moment I remove this 15, I will check for its level, and here some known null value is present. I will update this known null with this 15. Okay, and as this 15 don't have any of the children, I don't need to add anything to my queue. Moving forward, I encounter this 9, and I will work for this 9. I will update at its level, and its level was nothing but the level on which 15 get updated. So I'll update this 15 with the 9 this time, and I'll add its children. It have only the left children, so I'll add 12 only. Okay, moving forward, I encounter this 11, and this 11 means the level at which this 11 will be present. It will be nothing but null, so I'll update this null with the 11. So moving forward, there is only a value that is 12 which is lies in the queue. So I'll remove this 12 from the binary tree, and I will check for its position into the to the array list. Okay, a particular level and the array list, and here I come to know it resides in the level number 2. So I'll update its value with the 12. Similarly, I add these children, that is 13 and 14, and these 13 and 14 one by one get removed from the tree, and these values also update its values in the array list. 13 updated its value into the level 1, and 14 updated its value into the level 3. Okay, 14. So here you can see at last 0, 13, 12, 12, 14, 10 and 11. That is this 0, 14, 13, 12, 0, 4. Okay, so sorry, 0, 13, 12, 14 and 11. 0, 13, 12, 14, 10 and 11. These were the values. Nothing. These were actually the required output. These values are nothing but the nodes values which will be available to the user if we start looking at the binary tree from the bottom. Okay, now I hope you get the intuition of this question. This question is purely based on the vertical level order traversal. If you haven't watched that video, please go and watch that video, because unless and until you don't watch that video, you will not be able to get the solution of it. Okay, so I hope you get it. Let's move on to the Pepcoding portal and let's try to code it. Okay, so bottom view for binary tree, I hope it is visible to you. So now let's try to write the code. What will be your first part which will we write? At first we'll write the function of finding width. So public static void width tree node root int hl int answer. Okay, hl. Okay, int hl int answer if root equals to null. I personally feel that I don't require to explain you each and every line of the code which I'm writing right now, just because there is a dedicated video which lies on the YouTube based particularly for this question. It is my request you go and watch that video, just because uh, here I'm not going to explain what I'm writing and what are actually the concept of finding the width. Okay, I'm just going to write the code mat.me, and for answer 1, it will be nothing but mat.map hl comma answer 0. answer 1, answer 1. Okay, so at last what I'll do, I will make a recursive call to root dot left hl minus 1 and answer as a parameter. Similarly, another recursive call root dot right hl plus 1 and answer. Okay, so this is all the function of writing the calculating the width of a binary tree. Again, let me create one more thing, that is the vertical pair class. So let me create it. Why I'm creating? Just to calculate the vertical level order traversal. Okay, so the reason of creating this pair class you already know, and we have already explained it in the video. Okay, so moving forward, let's complete the code. If you want the reason of creating this class, please go and watch that video. Okay, vertical pair, it is a class. First thing is tree node equals to null. Similarly, int hl equals to 0. Vertical pair tree node comma int hl. Okay, let me update these values. This dot node with the node, and this dot hl with the hl, and this dot hl with the hl. So we have completed the code of vertical pair class. So let's move forward and complete the code within this function. Okay, this array list function. First thing first, I will create a linked list. At first I will create the queue. Okay, this queue will be of linked list tab. Linked list. Okay, linked list having for vertical pair tab. So yeah, vertical pair. Let me rename it as queue new linked list. So after that, let me create an array of min max. Okay, yeah, min max equals is an array new int of the size 2. Okay, so let me recursively call this function root 0 and min max. Now what I'll do, I'll calculate the length min max 1 minus min max 0 plus 1. Min max 1 min max 0. Okay, now we have calculated the length. Let me create a let me create a array list of it. Array list of integer is array list of integer. Let me rename it with answer new array list, and this will store all the data of all those nodes which will be available to the user if we start looking at the tree from the bottom position. Now let me initialize this tree with the values 0. Okay, here I'm initializing it with the 0, and we can also update it with the null. Okay, so length I plus plus and answer dot add 0. Okay, wait. So now let's write some code here. While q dot size is not equals to 0, we will write the function. Similarly, size equals to v dot size another recursive not the recursive, other iterative method. Okay, other iterative function size minus is greater than 0. So yeah, now let me remove the first value vertical pair, and remove pair equals to q dot remove first. Okay, remove first. Let me set its value into the set its value into the array list. Okay, let me update this value into the array list. Answer dot set rp dot hl. Similarly, answer dot rp dot node dot value, node dot value. So we are keep on updating the values each time. Similarly, as we have updated the value into the array list, now let's check whether like we have removed a node from the queue. We need to check whether it's left or left child lies or right child lies. If they lies, means if they actually exist, we need to add in into the queue. Okay, rp dot node dot left is not equals to null. We need to check it. Okay, similarly we need to check if rp dot node dot right is not equals to null, and if these values are non-null, what we'll need to do, we need to add it into the q dot add last actually add last new vertical pair okay, that is nothing but rp dot node dot left hl minus 1. Similarly here also q dot add last new vertical pair p dot node dot rp dot node dot right hl plus 1. So what we need to return at the last, we just need to return answer at the last, just because at last this answer will contains all those updated values which will be available to the user if we start looking at the tree from the end. That's all for this question code. We are going to run it, and if we encounter any of the error, we will try to solve it. Okay, so at first press this run button, and whether it will show any error. Yes, it is showing the error. Okay, so yeah, we encountered this error just because here we forget to mention the rp dot hl dot minus 1. Similarly here also rp dot hl plus 1. Okay, we can't access this value without the object. Okay, so yeah, it is accepted. Let's try to submit it. So yeah, it is showing the correct answer. I hope you get this solution approach for this question. If you like this video, hit the like button, share it with your friends, and subscribe to our YouTube channel. Till then, stay safe, stay healthy. Meet you in the next video.